Hello guys, welcome back to our channel. So Shomu sir, what are we discussing today?
Yeah, Harshal, we have a basic relative speed problem where one object is crossing another object. So we have two persons walking beside a railway track at respective speeds of 2 and 4 km/h in the same direction. Fair enough. A train came from behind them and crossed them in 90 and 100 seconds. So when a train is crossing any one man, it is basically crossing its own length, right? So the distance needed to be covered would be the length of the train, something like that in each of the cases. So the first person as well as in the second person case. But since it is coming from behind and crossing them, so the relative speed will be the difference of the speeds of the two objects, isn't it? So in this particular scenario, we have neither the length of the train nor the speed of the train, right? So we have to assume that to be something to begin with. And also then it says the time in seconds taken by the train to cross an electric post is nearest to. It says nearest to, so maybe some approximation will be involved here. But we'll come back to that later on. But what are we looking for? The time taken by the train to cross an electric post, right? So when it crosses the electric post, again, post is just a point, it's a negligible length. So the train is again crossing its own length. But in this case, the relative speed is basically the speed of the train itself. I mean, relative speed, you don't even have to think about relative speed, right? The electric post will be stationary. So essentially the length of the train, so let us consider the length of the train to be L and the speed of the train to be T. And since these speeds are in km/h, so I'll just consider the speed of the train as T km/h. Fair enough?
Right, correct.
Okay, so in the first case, so first person, the train covers passes the man with a relative speed of T minus 2 km/h, right? So train is T km/h, the first person's speed is 2 km/h, traveling in the same direction. Now, since it is km/h and these are seconds and everything, even the question is looking for seconds, so I'll convert this to meter per second. So I'll just write this as 5/18. I mean, initial calculation, this 5/18 will be irrelevant, but in order to figure out the L, this 5/18 is important. So let's keep that in check. So this is in meter per second now, and multiplied to the time. And the first person is covered in 90 seconds, right? So this should be the length of the train.
Right.
At the distance the train covers. Same thing for the second man. For the second man, it covers with a speed of T minus 4 km/h converted to meter per second and covers him in 100 seconds, right? Crosses him in 100 seconds. So this should again be the length of the train. So these two things are equal, right? So all you have to do is solve for this. So as you can see, this 5/18 goes up, right? That is irrelevant to calculate T out here. So you can just calculate whichever way you want. I mean, you can just multiply this as it is. So let me show the simplest of way for this. So we have 100T minus 400. You have 10T is equal to 220 or T is equal to 22. So we get the speed of the train as 22 km/h. Don't forget this is km/h. That is the speed of the train, right? Now coming to the length of the train, because that is also relevant. When the train is crossing the electric post, it is crossing with this speed, but it is covering its own length. So L is also important out here, right? So let us calculate L using either of these two information. So I'm just using the first one. So T is 22. So we have 22 minus 2, that is 20. Cross 5/18 cross 90. So this goes off as 5. So 5 into 20. 5 into 20 is 100 and then 5 multiplied. So that is 500 meters.
Right.
Isn't it? And now just divide the distance by speed to get the time. Remember to convert this to meter per second. So let's do that. So I'm just leaving it as so this is meter per second. So the time taken would be basically 500 divided by 110/18, right? So something like this happens. So this is 9,000 by 110 or 900 by 11. 9/11 is 81.81%. So 900 by 11 should be 81.81. This is exactly 81.81. So that is 82 roughly. I mean, if you're good with those basic percentages, 1/11 is 9.09%. So obviously 9/11, 9 into this, so 81.81. This should happen mentally. I mean, these things we have explained in simplifying calculation. Simplifying calculation is actually free in our course. So if anybody is interested, they can just subscribe to our website and get the course for free. There are a lot of calculation techniques that we have discussed in that particular brief course of simplifying calculation.
Sure. Even I would share the link of that module in the description.
Yeah,
so,
do that.
Yeah, so anyone would be able to check that.
Perfect.
Thank you, sir. Thank you for such a wonderful explanation. Thank you so much. Thanks everyone for joining in.
If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.